So we're going to continue to work with those properties that we learned on Tuesday, but we're going to expand upon them, if you will, using some geometry also. Very common types of questions. So let's review area of a circle. How do you find the area of a circle? Yes, pi r squared, right? How do you find the area of half a circle? True. And what about a quarter of a circle? Well, that's not a very good quarter circle. Let me try that again. Sorry. All right, so pi r squared over 4. So you're going to want to remember those things for today. That's basically it there. What else? What else? Here's something that's really kind of tricky. Today, I'm going to be asking you guys to find the area of something that looks like this too. Not using calculus, using geometry. How in the heck are you going to do that? Well, let me tell you. So first of all, you don't need to write this down, but you can just watch. I'm going to imagine there being a line here, right? So what I'm going to do is I'm going to find the area of the square, and I'm going to subtract from it the area of the quarter circle, right? And what's left is the area we care about. So what I would have you guys write down would be this much of it, right? I would say this is equal to the area of the square minus the area of the quarter circle, right? Where this side here, we'll call this S. I guess we can call it R. I want to call it R. All right. If that's R, right, then this is R squared, isn't it? And this would be pi r squared over 4. Because that side represents the side of a square, but it also represents the radius of your circle. Okay, so there you go. So that'll be something we're going to do later in day 2. So basically, we're going to be doing more integrals, but with geometry again. And these types of questions are pretty common, so we'll hopefully make some good headway here. So use the graph of f of x below to evaluate each integral. Okay, so the first thing is just because I know I'm going to need to. Now, you don't always have to do this, okay, but I already know where we're going with this problem is. I'm going to be asking you guys to find integral values. And so to do that, we're going to need to find area under the curve. And since these are all nice geometry shapes here, circles, lines, and stuff like that, I'm just going to use geometry. And they didn't give me an equation, so I can't do integrals, proper, right? So what I'm going to do is I'm going to be breaking this shape up into pieces that I can find the area of, like from here to here. That's a triangle, right? So what's the area of that triangle? No, it's not -2. -4. Base is 2. Height is -4. 2 times -4 is -8. Divide that in half. You got -4. Okay. I'm going to come back to the weird one here between 6 and 4. We'll come back to that in a minute. But for now, let's find the next area. This next area, which I guess I'll change colors here. The next area has a rectangle here, and it has a semicircle on the top, right? So what's the area of that rectangle? Okay. And how about that semicircle on the top there? I don't think it's 8 pi. No. So remember, this is a half circle, right? So it's the area of a circle cut in half. What's my radius? So it's squared 2, which is 4 pi over 2, which is, why is the radius 2? Because that's where the center would be, and my radius is from the center to the side. So the total area will come out to be what then? which we can reduce to just 2 pi. All right, let's do another piece here. How about from here to here? That's easy, right? It's 8 again. Let's make the area 8 again. America great again. No. Oh. That was bad, but it was funny. All right, so here we go. What's that one? 1. I think 2 is right. Base and height. 2 times 2 is 4. Cut that in half. 2. How about this guy over here? Kinda. Negative. All right. So the only one I haven't done yet is this guy here, and we talked about how to do that earlier, right? So I'm gonna do that on the side over here for you guys so you can watch it, because it's the part that's not horribly obvious. So basically, I want to find out what's this area, right? This weird looking little shape. And what we said before was, well, this shape is basically what you get when you take the area of a square and you subtract from it the area of that quarter circle there. And what's left is that little wedge down there in the corner. You guys good? All right, so now the length of this thing makes up the side of your square, so my square is 2, right? And it also gives you the radius of your circle. So what's the area of my square? And what's the area of my quarter circle? Well, let's work it out. I'm not sure. Let's see. Pi, and my radius is 2, and we're dividing it by what? 4, right? So those cancel, right? So it's just pi is the final answer. And so there's your answer. It's a weird one, but the area is 4 minus pi. Okay, so I can't really fit that in there, so I'm just going to draw an arrow and put 4 minus pi. Okay? So some geometry, that's it. We're just finding area. Okay. I feel like I should have some. Sorry, just a second. Wanted to look at something. I want to make sure I do just a couple different examples. Okay, so let's get rid of this real quick. Now we haven't really done any calculus yet, right? We're just kind of finding area, but I want to show you how the problems actually look. So what if I asked you guys to find this here? If I said, find me the integral from -4 to 8 of this function, which I'm going to call f of x dx. So what we have to understand then is that that's the area of the curve, right? And I'm going from -4 to 8. So, well, from -4 to 0, that is 2 pi plus 8, isn't it? So from here to here, we have 2 pi and 8, right? And then what's next? Plus 8. And then what's next? Plus 2. And then what? Minus 2. And that's where we stop, because we're stopping at 8, right? So we just put those pieces together. I ignored the brown and green piece over there, because green piece. No? Green piece? Oh, I thought it was. Anyway, I don't do politics. There's that. And this would be your final answer. Okay, so basically you're answering a calculus question by doing geometry because they want to make sure that you guys actually do understand that you understand.
Why did we ignore the rounding?
Good question. So the reason we ignored those is because my limits. I started at -4 and I went to 8. So I started here and I ended here. Yeah, so those limits are going to be key. All right, let me throw another question at you guys here. Making up a few different ones that you might see along the way. Suppose you guys saw this. Oh. Let's say all right, just don't write anything down, but just try to do it mentally really quick. And when you got an answer, raise your hand. Tell me what you think it is. -pi? Yeah? Good, okay. So he added the areas together right, and I wanted you guys to say that, but I didn't want you to write, and there's a reason. So basically, you guys see like this 4 here will cancel this 4, right? And this -pi is going to take one of the pi's away. And so you're left with pi plus 8. But here's the detail that's hard to notice. Where am I starting at? 0. And then I'm going to what? I'm going backwards. What happens when you go backwards? It changes the sign, right? So this is how I'm going to say to do these ones. Always make sure the little number's on the bottom. So if it's not, we're going to do that first. Okay? And then we're going to do the area adding thing. So the area adding thing says, okay, I'm starting at -8. I've got -4 on the left. Then I've got 4 minus pi. And then I have 2 pi. And then I've got 8, right? And when we put all that together, we end up with pi plus 8. But you do need to remember to distribute that negative in, which makes the answer, the final answer there, -pi minus 8. Now, the other way you could do it is just do the like what Graydon did at first and just change the signs of everything. You can do that too instead of, you know, writing all this work out. That works fine. Let me throw some other stuff at you here. Can I erase? You don't know. Okay. How about this? I don't think we need to do the whole thing. It's kind of unnecessary. Keep it small. Let's go from 0 to 4. Okay, so using our properties here, I'm going to use property number 4, which says that, and you know, you don't have to always write out all these steps, but I'm just going to be thorough here. Property 4 says anytime you have 2 expressions being added or subtracted, you can treat those as 2 separate integrals, right? So there's that. And then I'm going to use property 3 from yesterday that tells me I'm allowed to go ahead and take that 3 out, right? Because it's a constant multiplier. And on that last one, since this is just a constant, I can apply that property 6, where this represents the height of a rectangle and 4 minus 0 represents the base. You guys tracking with me on that, okay? Remembering those properties from Tuesday? All right. So there's that. So now that I've got this by itself, just the integral of f of x, now I can just look over here at my picture. What is the integral of f of x from 0 to 4? It's 8. So now I've got 3 times 8 minus 8, which is 16. Okay? So that's how we can use geometry and the properties to do some calculus without actually doing any actual integration. And in this case, you couldn't do the integration because they don't give you the equations, right? So I think that kind of covers everything that you might need to know. Let's go ahead and throw some at you guys here. Why don't you guys try this one? So you're going to want to start by, you're going to need to find all the areas, right? So do that first. Next, after that, you can start finding your integrals, and watch out for the ones where they put the bigger limit on the bottom, because you have to reverse it and make it negative, right? So let's talk about how to split up the area. So, because that's a skill, right? You want to make sure you know how to do that. And say like, so you should have realized, okay, right here we need a rectangle, right? Right here we need another rectangle plus a semicircle, okay? Here we need a little miniature triangle, and here we need another little miniature triangle. Now, some of you guys might not have done that little miniature triangle there, the orange one. Some of you might just did that whole big triangle there, which is fine. The only problem is if they ask you about like from zero, like -1 to 0, or from 0 back, it's nice to have that as a separate piece. So I would personally just treat this as a trapezoid myself and keep those two pieces separate. But you could treat that trapezoid and orange piece as one giant triangle, but like I said, as soon as they start asking you to do something different, like in between there, you're going to need to treat them separately, right? So I'm just going to have them separate. The other thing is this over here, you're looking for this guy, which we talked about already. That's the one we have to figure out using a weird method. So give you a little bit, like another minute or so. So there's our answers. We have -2. We've got, for the red, we've got the pinks as -4 and -2 pi. The little miniature triangles are each a half. The green one's negative, the orange one's positive. And that weird green, booger colored green is 15/2. I put 7, but it's 2. And then the brown space over there is 16 minus 4 pi. Got a couple formulas on the right in case you need to see it. But go ahead and take a minute and see if you guys can figure out these integrals real quick. All right. Walter, what did you get for the first one? 0. Any questions? All right. He's correct. Orion's not here today. Neither is Angelina. Neither is Andrew. Neither is Jonathan. But Zarina's here. Zarina, what'd you get for number 2?
8.
Huh?
8.
8. Oh, I agree. Questions? Okay. Next one, Thea. Thea, sorry. 2 pi minus 6. 2 pi. I think you're close. Just put -2 pi minus 6.
Oh.
Any questions about that one? You got it, or do you have a question?
No, I had a question.
Oh yeah, what's up?
From you.
Oh, okay. So we're going from -8 to -2, right? So from here to here. So if you just put these 3 numbers together in that interval, you would get -2 pi minus 6.
Oh, okay.
Oh yeah, no, we stopped before that. Yeah. Any other questions? All right, next one. How's about not Savannah? She's not here. How's about Amanda? 4 pi. Let me write. So you said -4 pi, like this. Okay, let's see. So we're going from 3 to 7. Yeah, that's fine. You wrote the numbers in a different order than this, but it's the same expression. You're good. That works. All right. The next one, I was going to call on you, Jimmy, but it's just kind of ugly. But actually, what I can do, Jimmy, is I can ask you this. What do we have to do on this problem that's a little bit different from all the other ones so far?
For 5?
Yeah.
What I did is I took out the 2,
Mm-hmm.
and then I made it negative, so the -8 was at the bottom.
That's it. Beautiful. So he found the main thing. So if you guys started like this, the rest of it I really don't care about too much because it's just more area stuff. But basically that 2 needs to come out to the front, right? And these limits are backwards. We got the smaller one on top, so we need to reverse it and put a negative in the front. After that, it's really just a matter of putting every one of these numbers in the parentheses, and we can stop. But if you guys wanted to, you know, tonight when you're bored and you finished all your homework, because you probably only have like what, a little bit of homework, so you'll probably be done by like what, 3, and then you'll have the rest of the evening to do nothing. So if you guys want something to do, you can try to get to this answer here. That was supposed to be funny. You guys didn't laugh, but if you guys want to, this is what I got. You can check me and see if I'm right. I not only did I, so like I said, FRQ, I would just take these numbers and put them all in here and be done. Okay? Multiple choice, you probably would need to get them all together to a common denominator. Oh, matter of fact, cross off the 2. I forgot to multiply the 2, so the 2 would go away. But that's what I would end up with there. And you guys can check me if you want. All right. So I want to do one more thing before we call it a day. It's more of the same, but a little bit different. Oh, that's interesting. Oh. There we go. All right. So go ahead and did I print that for you? No. Go ahead and write that down real quick, please. All right. So we're talking about the equation of a circle. Okay. Whenever you're doing a circle, you guys, this represents the center, H and K. And notice it's a positive H and K. So whatever those signs are, you're going to do the opposite sign. So if it says minus H, it's going to be positive H. If it says positive H, it's actually going to be minus H. You do the opposite signs. But what that represents is the center of your circle. Okay? The H and the K. The R represents the radius of the circle. Okay? The R represents the radius. So, if I gave you guys this, x minus 1 squared plus y squared equals 9, right? Well, what would my center be? One and 0, right? So you take the opposite sign, so it's positive 1. And this one doesn't have a number, so that would be 0. Now be careful here. What's the radius? The radius is r, not r squared. So what's the radius? It comes from the 9. But if this is r squared right here, right? And so if r squared equals 9, then that means that r is equal to 3, because you can square root both sides, right? So if you wanted to graph this, it would be here with a radius of 3. 1, 2, 3, 1, 2, 3. There's your circle. That's the equation of a circle. That's how you graph circles. So why don't I throw one of these at you guys real quick here. Why don't you try graphing one? How about x minus 2 squared plus y plus 1 squared equals 4. I'm going to try to graph that really quick. Okay, so now I want to talk a little bit more about this slide here. Now, a lot of times in these problems, the y is already solved for. Okay, so they don't have the y, it's not an implicit function, they have the y by itself. So I want to show you guys something here. You don't have to write this, but just follow my work here. So the first thing that we're going to do is we're going to subtract this big chunk over here to this side. Okay, so that's gone. And if I want to get y by itself, what else would I do? No? You would square root both sides. What special thing do you have to remember to do when you square root both sides? Good. There's a reason for that, and I'll explain in a minute. What's the next thing? I want to get y by itself. Add the k. So this last line that I'm writing, I would like you guys to write this. this is what we're actually going to be looking at, but I wanted you to know why it looks like this. It's basically a circle that's written in explicit form. Now when it's like this, here's your center. Negative h and k, but remember how the k we used to have to do the opposite? But since I put it over there, we won't do the opposite for the k anymore. Okay, for now, your center will be hk. You'll still do the opposite for h, but not for k when it's in this form, okay? And your radius it's still there, but it's just in a different spot now. It's a number that's a perfect square there in the beginning of your square root. So that's my radius. Okay? Now, this is another interesting fact. And we're going to make good use of this a lot this year. Positive and negative. A circle is not a function. A function is a line where for every x value, there's only one y value. When you have a circle, if I pick an x value somewhere in the middle, there's two y values that go with that because it has a top and a bottom, right? So that's not a function. But when you get y by itself, you're writing it as a function. So what we're doing is we're thinking of it not as a circle anymore, but as two half circles. This is a function, and this is a function. But together they're not. The positive one represents the top of the circle. The negative aspect of this represents the bottom circle. Okay? So, when you get y by itself, you're writing it as an explicit function, and when you have explicit functions, it has to be written as a function, and therefore the circle has to be written as two separate equations, so to speak, if you want to have the whole picture. All right? So, we're doing geometry areas today, aren't we? So what I'm about ready to do is I'm going to give you some equations of circles. It's going to be our job to turn it into a picture so we can do the area, so we can find the integral. All right? So that's the goal. Let's go ahead and do a couple of those real quick. So go ahead and, did I print this for you, I hope? Sweet. All right, so graph each function on the interval indicated first, and then we're going to use geometry to evaluate the integral. So here we go. What is my center for number 1? It's 2 and 1. Remember, you change the sign for the h, but when it's in this form, not for the k. So it's 2, 1. What is the radius? It's 2. The radius is the square root of this number right here. Okay? So let's graph that. 2, 1. Radius is 2. Now I'm not going to connect these dots yet. There's a reason, so don't connect them yet. But there's my circle, right? Here's the reason I'm not going to graph it. We're only going to graph half of the circle. Is my square root a positive or a negative? Is that a positive or a negative? It's positive. So which half of the circle is it? We're only graphing the top. There you go. That's the equation that we're being asked to find. Now this is the calculus part, right? That's all the algebra and geometry stuff there. But now it's time for the calculus. The calculus says find the area under the curve from 0 to 4. So I'm going from here to 4. So to do that, I'm going to need to find the area of this little rectangle here and the semicircle. So what's the rectangle? 4. And what about the top? That's a half circle, right? So pi r squared. I think it's 2 pi. I think 2. Because 2 squared is 4, right? 4 pi over 2 would be 2 pi. And we're doing a half circle, so it's 2. So we have our final answer then. I've seen integrals like this before. Before I thought of this geometry approach, I was looking at this thinking, nothing's going to work here. Like u substitution is not going to work. You're not going to get any way to find this integral by hand. You literally need to just do the geometry. There's just not a nice way to work it out that I know of. All right, so let's do another one here. Let's go ahead and take a look at number 2. So we're going to draw the picture, then we're going to do the calculus. Ready? Okay, so what is the... So why don't you guys write down what you think the center is really quick, and I'll call you in just a second. You write down what you think the center is. Neha, what do you think the center is? She's right. Now I want you guys to go ahead and write down what you think the radius is. And if you've got a question, let me know, but that is the correct center, by the way. So if you're not sure why, so you know. What do you think, Thea? What's the radius? Good. All right, next question I'm just going to throw out there to someone right away. Walter, top half or bottom half of the circle? Not sure? Okay, that's all right. So pay attention to this next part. Go ahead, grade it. Why is it the bottom, Grady? When your square root has a negative in the front, that's the bottom half. So we're graphing a bottom half circle, right? So let's go ahead and graph it. I've got a center at -1, +4. I've got a radius of 3. 1, 2, 3. And since I'm only graphing the bottom, I'm not going to do the top dot this time. And it would look like this. So there's our shape. So now the question is asking us to find the area from -4 to 2. That's from here to here. How the heck are we going to do that? Any thoughts? You could. You could. Oh, like this? Unfortunately, it's not a trapezoid because it's curved. Trapezoids have to be straight, so that won't work. Okay, so it's going to be a lot like what Pearl and Thayer are saying. It's basically the thing we got to find the rectangle. So here, you could do it 2 ways. You guys tell me which one you want me to do. One way is like this. Find the area of that bottom rectangle and then each piece. That'll be more like what we've done already. But we could also do it another way. You could think of this as one giant rectangle and subtract a half circle from it. What do you guys want to do? Giant rectangle, half circle? Okay. I think that'll work. I think it'll work. I think we'll be good. I'm scared. All right, here we go. So what's the area of the rectangle? 24, so that's, what's the base? So 24, I agree, okay. So 24 minus the semicircle. So what's the area of that semicircle? Huh? So what is the radius basically first? It's 3, good. And so it's going to be 3 squared pi over, it's 9 pi over 2. Which, you said 4.5? That's right. I'm going to leave it like that. There you go. So there's our answer. 24 pi minus 9 pi over 2. Okay? All right, last one there. We're kind of running out of time. But honestly, these are the ones that you actually see most often. The ones where they don't have this number or this number there. What do you think your center is in that case? It's the origin. It's 0, 0. Those are the nice ones. But let's go ahead and do this one real quick before we leave. So what's the center? It's 0, 0, right? What's the radius? Okay, so let's graph it. Top half or bottom half? I'm going to change something. Can you guys change this with me? Change that to a 0. Okay, the reason I wanted to do that is because if I'm going from 0 to 5, I only want this half, don't I? So I'm not going to do a semicircle. What am I going to do? A quarter circle. Okay? So that would be pi r squared over 4, which is 25 pi over 4. Okay? And that's where we'll stop for the day. But